Welcome to homework.
Okay, we've got to determine how to synthesize 2-phenylhex 3-ine-2-ol, starting from acetophenone. Well, first let's just see what we're trying to synthesize and what we're starting from. So, to begin with, let's look at the 2-phenylhex 3-ine-2-ol. So we know it's a chain of 6 carbons, it's got a triple bond in there, it's got a phenyl group, an OH off the second carbon. So let's see, one, 2, 3. This is where the triple bond should be. That's 4 carbons, 5 carbons, 6 carbons. And at carbon 2, we should have an OH and a phenyl, pH. Okay, that's what we're trying to make. And we're trying to make that from acetophenone. So acetophenone is actually going to look kind of similar here in a way, or at least I'll draw it in a way that might make the similarity more apparent. Specifically, I'll kind of color this carbon blue in both cases so you can see which carbon is which, or what the relationship between our starting material and our product is. Right, so this blue carbon has oxygen, phenyl, methyl. This blue carbon has oxygen, phenyl, methyl. The difference is that in the product, we've got an OH instead of a carbonyl, and we've added a chain of carbons, 1, 2, 3, 4 carbons, beginning with a triply bound carbon. So if I were going to go about this retrosynthetically, I would consider breaking that bond and considering what I could add to get this bond created. Now, in fact, if we have just a general case where we've got a ketone, let's say we've got groups R and R prime, and we add what's known as an acetylide. That's a hydrogen, carbon, triply bound to a carbon, and this is a negative ion. And then we follow that up with just some water. Eventually we'll hydrate it. What we're going to end up with is R, R prime, OH, and H. Now the thing is, we can do the same thing, but replace this H here with an R group. Let's call it R double prime. R double prime. Okay. So if we look back at our starting material, we kind of have this correspondence, right? Like R, we can call this phenyl group R prime, and we can call this new group that we added, at least we can refer to this back half of it as being sort of like the R double prime. So we want something that looks like this. We want a reagent that looks like this, which can react with our starting material. It turns out you can make these acetylides by reacting any old alkyne, so R, carbon, triply bound to carbon, with an H at the end. If you react these with NaNH2 in liquid ammonia, NH3, you will get exactly the nucleophile you're looking for. You'll get an acetylide. So really all that's left to do is determine exactly what alkyne do we need to give us the correct acetylide that we can react with our ketone to give us our final product. Let's scroll down a bit here. Maybe I can bring this down with us again. Okay, great. So we want something that looks like this, which means it probably came from, or it implies, this molecule. So to start from the beginning, we say, what is that? That's like one, two, that's one butine. If we take our one butine and we react it with NaNH2 and ammonium liquid, right? Now we've got the nucleophile that we wanted. We can react that with our starting material, right? We've got the phenyl and the methyl. Okay, this is going to give us O minus phenyl, and this will be our substituent that we were trying to get. And finally, we can react it with maybe some acidic water or just H plus in some form to protonate our alcohol. And get the product we were looking for.